Hello, I am Hyung-gun. For my term project, I implemented .NET++ with engineering components dataset. The dataset enables the data-driven feature learning for the mechanical components. Exploring the descriptor for mechanical parts is essential to the computer vision, manufacturing, and the mechanical engineering domain. I implemented .NET++, which is a state-of-the-art 3D object classification algorithm with a mechanical components dataset. Further, I evaluated the feature representation of .NET++ by performing shape retrieval and visualizing extracted features to examine the behavior of a network of mechanical components. In this slide, I will briefly explain how .NET++ works. .NET++ is a high-performance 3D object descriptor that uses point cloud dataset as an input. .NET consists of FSP, iterative Fartist point sampling, and MRG, multi-resolution grouping layers, along with .NET layer. Through these layers, .NET++ can extract local contextual features of the input data. For this reason, I assume these networks can be a good descriptor of the granularly distributed dataset. Mechanical components dataset is dataset I collected for training features of mechanical parts. The dataset consists of mechanical parts such as bolts, nuts, and screws, and so on. The dataset has 18,000 data with 25 classes, and these are the example of mechanical components dataset. I performed classification tasks to assess the performance of .NET++ for the mechanical components dataset. I used total accuracy and balanced accuracy, which is average accuracy over every classes, to evaluate classification task. I experimented with how point cloud density affects the results in point cloud-based algorithms. From the experiment's results, the performance increases as the density of the point cloud increases, as shown in a PR curve on the figure. However, the enhancement of the results saturated as density grows. This behavior appeared in classification experiments, which shows that the density of the point cloud is an important factor. For the retrieval task, I used the trained .NET++ model for classification as the feature descriptor, and calculated cosine similarity between feature vectors for every data. The images in the blue box are the query of the shape retriever, and listed the image based on the closest cosine similarity. The images in the red box represent a different class with a query. Quantitative evaluation of the retrieval task also shows relatively high performance. I visualized the feature extracted from the networks to see how well the network grouping the data. A widely used dimensionality reduction algorithm, T-distributed stochastic neighbor embedding, is used for projecting features to the 2D space. Each point corresponds to a data, and the same color represents the same label. We can see that the mechanical components are very clearly clustered in their subgroups. In conclusion, I implemented .NET++ using the mechanical components dataset and analyzed the experiment's results. The network shows high performance in retrieval and a classification for a given dataset. And I can conclude that .NET++ can be a good descriptor for the engineering components. Thank you.